Science, chapter number 1, Matter in Our Surroundings, part 3. In earlier classes, we learned different states of matter. We all observed that due to change in the force of attraction between atoms, different states exist. Now we will discuss, can matter change its state? What actually happens during this change? Children, let us consider a common example, water. Water exists in three different states: solid as ice, liquid as familiar water, then gas as in the form of a water vapor. Now we will see effect of change of temperature. To know this, we need to make a simple activity by taking a burner, beaker, solid ice. Here I am using crushed ice and a thermometer for recording temperature of the ice here. First, what we have to do is, let us make a simple setup by taking a beaker containing solid ice. You can use crushed ice also, then burner and thermometer. Initially, in the first case, at the first step, we have to note down, that is, fill up the beaker with crushed ice, then note down the temperature of the solid ice. Isn't it, children? What we have to do at first step, we should fill half of the beaker with crushed ice or solid ice, and we have to record the temperature of the solid ice. Then, in the next step, we have to supply heat to the beaker. What it happens, the temperature becomes increases. Due to increase in the temperature, the solid starts converting into liquid. Isn't it, children? Due to the application of a heat, the solid changes its state from ice, that is solid ice, to liquid water. Children, this stage is because of due to on increasing the temperature. This can be called as a matter changes its state due to change in the temperature. What we are doing here? We are increasing the temperature. What happens actually when we increase the temperature? The molecules or the particles starts increasing. They gains more kinetic energy with the increase in the temperature. When the particles gains more kinetic energy, they starts moving freely. They starts vibrating, isn't it? They overcome the force of attraction. Whatever the heat we are supplying to, it will be used to overcome the force of attraction present between the particles. So now the particles are free to move, and now at certain temperature, the solid particles, they overcome the force of attraction and started moving freely in the beaker, isn't it? That's why we can call it as at certain temperature, the particles of solid turns into liquid particles. They will overcome the force of attraction. And we can note on in the second step, the temperature at which the solid becomes liquid. We have to do two major things. Initial temperature of the solid is recorded. Similarly, at what temperature the solid has converted into liquid is also noted. From these two observations, we can say that there is some point at the temperature, there is the temperature at which the solid starts converting into liquid, and atmospheric pressure is called melting point. Isn't it, children? We can define melting point as the temperature at which solid converts into liquid at atmospheric pressure is called melting point. Children, the melting point of ice is 0 degree Celsius. Then we will do same experiment or same setup by taking a water. Instead of a solid ice, we are using the water. Means liquid form of a water we are taking here. Isn't it? The same setup. Thermometer also using, burner, that is for heat purpose, burner we are using. Instead of a solid ice, in the next step we are using water. What we have to do first? We have to record initial temperature of the water. After supplying heat, we have to note down the temperature of the water where it started changing into vapors. Isn't it, children? Two major things we did. At first, we have noted down the temperature of the water. Isn't it? When we kept half of the beaker with water, the temperature of it recorded first. In the next step, we are after supplying heat, the temperature of the water where it started converting its state is recorded. So the temperature at which the liquid starts converting into gaseous form, that is vapor, is called boiling point. Isn't it, children? Now we will define boiling point, the temperature at which the liquid starts boiling. Isn't it, children? The liquid starts boiling. The temperature at which the liquid starts boiling at atmospheric pressure is called boiling point. The boiling point of a water is 100 degrees Celsius. Isn't it, children? The boiling point of a water is 100 degrees Celsius. Now we will record all these two main important points. What is melting point says? The temperature at which solid becomes liquid at atmospheric pressure is called melting point. Similarly, the temperature at which liquid starts boiling at atmospheric pressure is called boiling point. Why we are learning these two means the solid, that is melting point, and a boiling point is the main criteria for solid or a liquid in understanding whether the given substance is a pure or not. Isn't it, children? What actually when the solid starts melting? Isn't it, children? What actually happening during the change of a state of a matter? Children, when we recorded these two temperature, initial temperature of the solid and when it converts into another state, these two temperature also becoming same. That is, in the thermometer, these two temperature, it is giving around 0 degrees Celsius. Isn't it, children? Though we have supplied continuously heat to the beaker, but in the thermometer, we are recording same value. Isn't it? A question will arise. Where went that heat? Heat energy where it lost? Isn't it? Yes, there comes. That is latent heat. Children, what is mean by latent heat? Yes, children, in the first case, both the temperature are giving same. That is 0 degrees Celsius we are getting in the thermometer. Similarly, in the second case, in the boiling point also, we are getting for the initial temperature and liquid boiling point also same. That is 100 degree. The boiling point of a water is 100 degrees Celsius. Isn't it? Where went then heat? Isn't it? Our question is, where went the heat what we have supplied? The energy, that is heat energy used in overcoming the force of attraction between the ice particles in the first case, that is in solids. Similarly, the heat energy is used in overcoming the force of attraction in the water particles. And this hidden heat energy is called latent heat. Isn't it? Latent heat is defined as hidden heat energy is called as a latent heat. Now it's time to define latent heat of fusion and latent heat of vaporization. Children, fusion means the melting point where solid converts into liquid. The transfer of a solid state into liquid is called fusion. Now we will define latent heat of fusion. The amount of heat energy is required to change 1 kg of a solid. We need to take some particular value, children. So we are using 1 kg of a solid into liquid at atmospheric pressure at its melting point is called latent heat of fusion. Once again, I will repeat, children. The amount of heat energy is used to change 1 kg of solid into liquid at atmospheric pressure pressure and its melting point is called latent heat of a fusion. Now we we will define latent heat of vaporization. It is based on boiling point, children. That is, the amount of heat energy is required to change 1 kg of liquid into vapor at atmospheric pressure at boiling point is called latent heat of vaporization. That is, once again I'll repeat, the amount of heat energy required to change 1 kg of liquid into its vapor. See here, liquid is converted into vapor and atmospheric pressure at its boiling point is known as latent heat of vaporization.
The SI unit of temperature is Kelvin. It is represented by letter K. You know, children, the SI unit of temperature is Kelvin. But often while solving the problems, we need to go for conversion from Kelvin scale to Celsius scale or Celsius scale to Kelvin scale. Suppose if we want to convert from Kelvin scale to Celsius scale, then we have to make subtraction with the given temperature. We have to subtract the value 273 minus the given temperature. Isn't it? To convert Kelvin scale to Celsius scale, we have to subtract 273 minus given temperature. Similarly, suppose if you want to convert Celsius scale to Kelvin scale, then we need to add 273 plus temperature. What the given temperature will be there, no? That should be added to 273. Once again, I'll repeat. To convert Kelvin scale to Celsius scale, you have to do subtract 273 minus given temperature value. Similarly, to convert Celsius to Kelvin scale, you have to add 273 for the given temperature. So children, different materials exhibit different states of matter. So far what we have discussed is different materials exhibits different states of matter. Means they'll convert solid to liquid, liquid to gases. There are also few substances which convert directly solid to gas without changing into liquid. Isn't it? For example, when we take ammonium chloride solidified, that is solidified ammonium chloride, if it get heated for some time, it changes solid ammonium chloride to vapors ammonium chloride will get. Isn't it, children? When we heat, that is solid ammonium chloride, it get converted into vapors state ammonium chloride. So we can say that that is a substance which convert from solid to gas without changing into liquid and vice versa at given temperature is called sublimation. What is that? It is called as a sublimation. Previously we learned that changing of a solid into liquid is called as a melting or fusion. Now what we are learning here? The changing of a state from solid to directly gas, not to liquid. Without undergoing any change to liquid, it is converting into gas. Similarly, vice versa, gas to solid. Such a change is called as a sublimation. So far we discussed about if temperature increases, what happens to the state of a matter. Now it's a time to learn effect of change of pressure. If pressure is applied to the substance, what actually happens? Is there any change in the state or not? If it change, whether it converts solid to liquid or directly to gas or gas to solid, we will see. Different materials changes its states due to the presence of a distance between the particles. Isn't it, children? And for example, if the substance is kept under pressure and if we compress the gas, what changes they occur? Now we will see. For example, have you heard about that is solid carbon dioxide, children? It is also called as a dry ice. What happens means when we apply pressure and decreasing the temperature, they can make liquefying the gases. Means they will convert solid to directly gas. Have you heard about solid carbon dioxide? When it is stored under pressure, when it is stored under high pressure, it just converts solid carbon dioxide into gaseous state. Isn't it, children? It just converts solid state into gaseous state. It means that solid carbon dioxide get converted into now dry ice. So we can say that by applying pressure also we can change the state of a matter. Isn't it, children? There are different states of a matter. On increasing or decreasing both temperature and pressure, we can change the states of matter. So dear children, there are few substances which converts solid to liquid, and that method is called as a fusion. That process name is called as a fusion. The process of converting of a solid into liquid is called as a fusion. See here, states have changed. Solid state is converted into liquid and the process name is called fusion. Similarly, the liquid state gets converted into gas and it is called vaporization state process. Then gas to solid state is called as a sublimation. And also we make vice versa, children. That is conversion of a liquid into solid. Liquid state to solid state conversion is called solidification. Then conversion of a gas state into liquid state is called condensation. Then the last one, conversion of a solid to gas or gas to solid is called as sublimation. So we can conclude that due to change of a temperature and pressure, the different states of matter also exist.